Hello everyone, welcome back to Codeverse Coders. So today we'll be starting with your software engineering subject. In this we'll be covering UML diagrams, coupling and cohesion and code refactoring today. First we'll do coupling and cohesion and code refactoring. After that we'll be making some UML diagrams. So let's start. So what are UML diagrams? So UML stands for Unified Modeling Language. Unified Modeling Language. So basically, it is a standardized general purpose visual modeling language in software engineering. It is used to visualize, specify, construct, and document the structure and behavior of software intensive systems. So we'll write visualize plus specify plus construct. I'll write it below. Specify, visualize, construct plus document. So in these type of diagram, we have class diagram, use case diagram, sequence diagram, collaboration, activity, and state chart. So in class diagram, we basically focus on the structure part. And this is a static diagram. Use case is showing user interaction. It is also a static diagram. Sequence, time-based flow, and it is dynamic in nature. Dynamic means which can change. Static is which does not change. Collaboration, object relationships, dynamic. Activity is for workflow or process, that is also dynamic. And state chart for object states, this is also dynamic. Now, if you'll see this diagram, one is your structural diagrams and one is your behavioral diagrams. Now, which all do we have? Class diagram, object diagram. We'll see one example on object diagram also. Use case, activity, sequence. I think that's all. State machine or state chart, they are different in nature. But let's see. So basically these we will be covering. So let's start with the topic coupling. So what is coupling? Coupling is basically how one module depends on another. So these are all the types of coupling: control, common, content, data, stamp, and external. These are from worst to best. Now let's see the types. So first we'll see with content coupling. Now what all I will be telling you or writing on this slide will be from my notes. So you can refer to either of the definitions. So content coupling is basically also known as pathological coupling. So this is when one module relies on the other module's internal working, that is accessing local data of another module. One module directly modifies another's data, that is dependency. Next is your common coupling. Common coupling is when multiple modules read or and write access to some global data. We also call it global coupling. Read and write access to global data. And it is a shared resource. Next is your control coupling. So in control coupling, two modules are basically controlled coupled if one of them decides the function of another module or changes its flow of execution. Control coupling is one module controlling the flow of another. One module controlling flow of the other module by passing info. So this is control coupling. Next we have stamp coupling. Stamp coupling is also known as data structured coupling. When multiple modules share a common data structure and work upon different parts of it. Share data structure and work upon its different parts. This is your stamp coupling. Next is your data coupling. Data coupling is basically when two modules interact with each other by means of passing data, that is parameters. If a module passes data structure as a parameter, then the receiving module should use all its components. Use its components. This is passing only required data as parameter. Is a data coupling. Next, we have external coupling. In external coupling, this occurs when two modules share an externally imposed data format, communication protocol, or device interface. That means dependence on external systems. In easy words, you can understand this by external system, that is APIs or files, file or database usage. Then there's one more that is not listed here, that is message coupling. Message coupling in bracket you can write as low. This is basically the loosest type of coupling. This is achieved by state decentralization. And component communication is done via parameters or message passing. Parameter or message passing. This is your message coupling. Now, the next topic is cohesions. So basically, before starting cohesion, I want to make you all write down something. Please write this down. Now, one is your subclass coupling. That is, it describes the relation between child and parent. And second is your temporal coupling. When two actions are bundled in one module just because they happen to occur at the same time. That is bundled as they occur at same time. So this is also part of your coupling. Ideally, high cohesive and loosely coupled considered to be the best. So high cohesion and low coupling is considered best. Now let's start with coupling now. So coupling is basically how focused a module is. It refers to what the class can do. Low cohesion would mean that the class can do a great variety of functions. As for coupling, it refers to how related or dependent to classes or modules are with each other. So you can write this down. What the class or module can do. So let's start with its types. So first is your coincidental cohesions. Random or unrelated tasks. They have no connection with each other. Second is your logical cohesion. Similar types of tasks that are grouped with each other. Next, temporal cohesion. In temporal cohesion, tasks are done at the same time. Procedural steps follow sequence, ordered execution. Communicational cohesion, same data is used. That is a shared data set. Sequential cohesion, output of one is input of next. Functional is single well-defined task, one clear purpose. Now, coincidental cohesion is basically the worst cohesion. It is not related but bundled together. It is harder to understand. Harder to understand and not reusable. Then is logical association. Whatsoever logically related thing that is put together. That is input, file handling, error handling, etc. Temporal cohesion. Same time executing things are put together. This is your time-based cohesion. Next, procedural is based on a procedure. Procedure. Communicational is related input and output are clubbed. Input and output clubbed. Based on sequence or relation between modules. Based on sequence or relation between. Sometimes the definitions could be a little bit like here and there. Like you may be seeing same data used is mentioned here, but you have altogether a different definition here that input and output are clubbed based on the sequence or relation between modules. Now that is why I'm making you write these definitions also. Next is your functional. Functional write down. It is the best and it has a well-defined function with related tasks, attributes, and methods. So this is all about coupling and cohesion and its types. I hope we have covered all of them. Now next, this is a table for you all for your reference. This has all the types, its meanings, and easy identification trick. So try learning them like content coupling. Accessing internal variables. Common coupling means there's something in common, global variables. Control, remember teacher, flag, switch, if. Stamp coupling, large object or structure past, but we use only parts. Data coupling, required data that is parameters. External, you use external systems. I hope this will make learning easy. Next, coincidental cohesion, unrelated task groups, that is random functions. Logical, switch or menu based, similar category tasks. Temporal, tasks done at the same time. Procedural, steps in sequence, ordered execution. Communicational is shared data set. Sequential means a pipeline process. Basically, A to B to C to D, like a pipeline. Functional cohesion, one clear box. This summarizes all that we have done in coupling and cohesion as of now. Coupling should be low and cohesion should be high. So let's do a case study based on this. So software company is basically developing an online food delivery system containing multiple modules. The user module handles login, profile management, order placement, and directly accesses the database tables to retrieve and store user and order information. The order processing module receives order details from the user module and processes them step by step. It uses a control flag payment type, mode of payment, and passes entire user object. That is all the details related to the user to the payment module. Payment module processes further based on the received flag and accesses global variable discount rate. It invokes internal methods to update order status. It receives the order ID and prepares the food without depending on the internal details. Then when it is prepared, it performs scheduling and tracking in a step-by-step manner. So this is your software company, online food delivery system. Identify whether modules are tightly coupled or loosely coupled. Explain the type of cohesion in each module. What problems may arise if two modules have high coupling? So let's see. Now user is interacting with the database. Here, content coupling, tight. Order to payment, passing full object, and also flag control is there. So stamp and control coupling. Payment to global data, common coupling. It is accessing the global discount rate. It is mentioned there. Payment to order, it causes internal methods, content coupling. Restaurant to order, data coupling. Only order ID is passed. Then output to input flow, sequential coupling. System is mostly tightly coupled except restaurant and delivery parts. Next cohesion, user module logical, handle login, profile, order. Order processing, steps, step by step. It is written there in the case study also, step by step. Payment, logical, restaurant functional, only prepares food. A specific task. Delivery module, sequential cohesion, step by step. Problems with high coupling are change impact, poor maintainability, low reusability, difficult testing, reduces flexibility, higher development cost. Or you can write it in the form of a line. The system demonstrates poor design due to high coupling in the core modules. Only restaurant module shows good design, that is functional cohesion plus low coupling. Refactoring should aim data coupling and functional cohesion. Try to mention at least 4 points in your answer, even if it's 1 mark. Now let's see this question. Two systems are designed as follows. System A using global variable. Global variable means global or common coupling. And control flags between module. That is your switch case and all. So this is control coupling. System B passes only required data through parameters and each module performs a single task. functional and passes only required data. Data coupling. So system A, tight coupling, low cohesion. System B, loose coupling and high cohesion. As we saw, the best coupling or the best cohesion is in the case of functional because it is a performing a clear specific task. Whereas in system A, we can see it's a global coupling. So global has some disadvantages also that it can be changed easily. And control is your coupling. Reverse thinking question. A system is highly reusable and easy to maintain. Can you infer about its coupling and cohesion? Justify. Low coupling and high cohesion. Now, this means that dependence between modules is low and dependency within modules is high. Let's say it is block A, block B, block C. Each have their individual tasks and are connected together, but not in such a way that changes in one will be effective in the other. So even if we put A from here to a separate part, that is D, still B and C can work and will not be much affected by removing A. So this is independence and focused modules. Next case study. A hospital management system is being developed with multiple modules. The patient module handles registration, updates, and discharge. But instead of directly modifying bill records, it sends complete patient details to the billing module. Billing module calculates charges and generate a control flag to payment mode. Shared global variable service tax access. Doctor module manages and interacts with receiving test reports. Laboratory model processes and forwards to doctor module. Generates summary by using large shared database containing billing details and all. So based on the above case, identify whether the modules are tightly coupled or loosely. Explain the type of cohesion in each module. Also discuss the problem that may arise. Now patient to coupling, billing is a stamp coupling. Full data is passed but partially used. In billing module, we saw the payment flag, payment mode flag, and the service tax global variable. That is control coupling and common coupling. The report module has a shared structure. Now, from the lab, the reports are sent to the doctor module on a sequential manner, therefore mostly tightly coupled. Cohesion, logical cohesion. Multiple operations are being handled. Billing is also flag based, so logical. Doctor module is functional. Laboratory module is functional and report module is communicational cohesion. Problem is high coupling and low reusability, reduced flexibility, increased cost, computational cost, and difficult maintenance. Better design is low coupling, high cohesion, dependence within modules, and dependence between modules. Now we go to code refactoring. So we have been given a code and we have to refactor that code. First, let's see what is code refactoring. It is used to improve the code readability, reduces the duplication of code, enhances maintainability, improves structure and design, and makes code easier to test. So now you've been given a C code where you calculate the sum and the product. Now both are calculated in the same function. Don't you think they should be different function? Where one function should calculate sum and one as product. So this is what we have done. And this method is known as extract method refactoring, where we remove the repeated logic, improve readability and cohesion. Next, this is the question. So this is the question and this is the solution. Now it is calculating the total marks, and then if your total divided by number of subjects is greater than 50, you are pass. Then if your marks in any subject is less than 40, low, otherwise okay. So here extract method is also used. See, total is now a separate function. Print result is a separate function. Print grade is a separate function. Just look, the same implementation is being done just in different functions. The header file is the same. Now main is also added. Here it was all a single function, main was optional. But now you have different methods. Their correlation into one main method, and how do we call them? And it works same as the uh, process function. Now this is very important. How the process function is printing and working should be the same as in when we are distributing into different functions. Like first, if calculate total, you have to calculate the total first. You can't print the result first. Although it is not possible to do that, but in different scenario, it could be possible. So basically, first is your extract method, which we have talked about. Then is your inline method. Remove unnecessary small functions. Rename variable, use meaningful names. Replace temp with query. Remove temporary variables. Why not use a plus b directly? Move method, shift method to appropriate class or module. Printing non-module, move to correct one. Remove the duplicacy. Same loop twice, single function. You make a single function like a and use it twice instead of writing a into a twice. That does not make sense. Instead, you make a function void power, and whenever you want to use, you just call the power function. Simplify condition, make complex things easy. Like why write a equal to true? Why not write only if a, or if a equal to false, not a? Introduce parameter. Pass tax as an argument rather than writing tax equal to 10, tax is equal to tax plus 10. Instead, make a function and pass tax as a parameter. Encapsulate getter and setter. Restrict direct access. Public. It means public or private. Now it is really important that all variables in any function, whether it is Java or any language, they should not always be public. You should use and you should always try to incorporate the use of private variables and protected variable. Whenever using inheritance, try to use the protected variable part. Split function, divide, make a function like there is a function implementing plus, minus, multiply and divide. Why not make four functions? 1 plus, minus, divide and multiply. So this is a very important table. Please remember whatever is written here. So this is all for your first lecture in software engineering. We'll cover UML diagrams in the next lecture. I've given you an overview of what are the types of diagrams that we'll be covering. I think it has been a long video. It's been 30 minutes. So I'll continue UML diagrams in the next video. So if you have any doubt, do mention it in the comment section and do study these case studies really well because they can be asked. If you like the video, do like, share, comment, and subscribe to my channel. So thank you all. Bye bye.